Welcome back to part 2. I'm just going back to the two questions which there was an error on. So this is the first one, question number 7. In my answer I wrote 7064 minus 502 equals 7064. I made an error when it came to adding up, when it came to checking. I found the final answer going back using the inverse operation to be the original number that the question starts with. However, I should have written down the answer of 6562, which I didn't do. Well done to those students who spotted these. The second one is question number 10. I've already corrected it here. It was supposed to be 308 minus 10 is 298, which I showed in my working out. However, when I came to writing the answer, as I was doing my check-in, I reverted back to the original answer of 298. So I wrote 298 subtract 10 equals 298, which of course is incorrect. Okay, so going on to question number 11. So we've got 270 divided by 3. You can use mental methods, which I will show you how to do later on, or again you can use the short division method. If we use the short division method, 2 divided by 3 is not possible. Cross that out, carry the 2 across. That gives us 27 divided by 3, which gives us an answer of 9, and that 0 gets carried across. So that gives us a final answer of 90. Okay, question number 12. 5400 divided by 9. Okay, so 5 divided by 9 is not possible. That's going to be a 0. Carry the 5 across. 54 divided by 9 gives us an answer of 6. Now, if we carry the zeros across, that is going to give us an answer of 600. If I want to double check that, I can of course use the method of, again, inverse operation. And I can do 9 times by 600, and that would give me an answer of 5400. Question number 13. 60 divided by 15. Now this you can do mentally, or you can do it with the different methods of division. It's up to yourself. But I'm just going to write the answer, which is simply 4, because I know for a fact 60 divided by 2 gives me an answer of 30. If I take 30 and divide that by 2, I get an answer of 15. So how many times does 15 go into 60? I'm going to use something slightly different here, and it's called the Singapore bar method. So if, for example, this is the Singapore bar method. I will be going into this in a bit more detail later on. If the total amount equals to 60, each one of these represents 15. Then if you add them together, 1, 2, 3, 4, 4 of those 15s equal 60. Question number 14. Something equals 5776 minus 855. So again, use the inverse operation. 855 plus 5776. So let's do the addition here. 5 plus 6 equals 11. There's the 1, carry the 1 across. 5 plus 7 is 12, plus the 1 is 13. Carry the 1 across. 8 plus 7 is 15, carry the 1, which is 16, carry the 1 across. 5 plus the 1 gives an answer of 6. So, there we go, oops. Okay, so our answer is 6631. Now, if we would like to double check, we can use the inverse operation as before. 6631 subtract 5776 So 1 minus 6 is not possible, so we carry across from the 3, which gives us 2 there and 1 here. 11 minus the 6 gives us 5. 2 subtract 7 is not possible, so again we're going to carry across from here, so that's 5, and this becomes 12. 12 subtract 7 is going to give us an answer of 5. Moving on, 5 subtract 7 is not possible, so we borrow from here, that's 5. This becomes 15. So 15 subtract 7 gives us 8, and 5 subtract 5 gives us an answer of 0. So our final answer is 855. Okay. Oops. Right, question number 15. It is 3,050,020 equals 3 million plus something plus 20. So we need to split this number up. Let's write it out to start off with. 3,050,020. Okay, so if we subtract 3 million to begin with, that's going to give us an answer of 50,020, and then we've got a 20 here, so we can take another 20 off. So subtract 20 again, and I'm going to have to move over to here. That's going to give us 50,000, and that is our final answer. Question number 16. 10 subtract 5.4. So I'm going to use a different method. I'm actually going to go down the page. So let me just get rid of this. 10 subtract 5.4. I need to align the digits so that they are actually equal. I'll just start off with this again, sorry. Okay. I've still not discovered how to etch in all of the missing sides once I actually go onto the white, get rid of the ink. So that's something that I need to try to discover. Okay, going back to the blue. So 10 subtract 5.4. Okay, so if we put the decimal point in, it should go there, and then we can fill this with a 0 just there. Now you can do this mentally in your head, or if you're going to use a written method, you would take the, so for example, you would borrow the 1 from this side, make that into a 10, and then again you would borrow from here, that's going to be a 9, carry the 1 across, and that's 10. So now you can actually work this out. 10 subtract 4 is going to give us 6. 9 subtract 5 is going to give us 4, and 1 subtract, there's nothing to subtract from, so the final answer is 4.6. Question number 17. So we've got 5/7 plus 3/21, so 3/21, and we need to get the same denominator, so I'm going to keep this the same, and I'm going to multiply this by 3, the whole fraction. 7 multiplied by 3 gets me 21, 5 times by 3 gets me 15, so now I can simply add the numerators. 15 plus 3 is 18/21. If I simplify that, it is possible to divide both by 3. So that gets me 7 at the bottom. 18 divided by 3 gets me 6. So the final answer is 6/7. Question number 18. 0.1 divided by 100. Now, if you know your rules of division, you would know that the numbers move to the left when you are dividing and move to the right when you are multiplying. So if I was to take this here, I would keep the decimal place. So I'm going to use these boxes to represent a place value. If I keep my decimal point there, okay, well, if I'm dividing by 10, I know for a fact my decimal point stays in the same place. Do not forget, it's the numbers that move, not the decimal places. Sorry, it's the numbers that move, not the decimal point. So here's the first decimal place, this 1 over here. That has to move once if I'm dividing by 10, or twice if I'm dividing by 100. So that means I have 1 0 there, another 0 there, and 1. So the 1 has gone from here to, this 1 has moved once and twice. So because it's moved twice after the decimal point, I need to put in the 2 zeros. So the final answer should be 0.001. Question number 19. 3/4 of 1,000. So to work this out in your head, you could probably do that in your head straight away, and that would be a simpler method. If you are doing a written method, then it would be 3/4 multiplied by 1,000. The 3 times by 1,000 is 3,000 over, and the denominator stays the same, 4. So 3,000 divided by 4 should give you an answer of 750. Question number 20. 785 times by 23. So the question's already been set out, we just need to work it out. So 5 times by 3 gets me an answer of 15, carry the 1 across. 3 times by 8 gives me an answer of 24, plus the 1 which is 25. Okay, 3 times by 7 is 21, plus the 1 there is going to give me 23. Okay, right, because we are multiplying 20 by 5, we always put the 0 down here, so it should be 2 times by 5, which gives me an answer of 10. So I'm going to carry the 1 across there, that's 10. 2 times by 8, which is an answer of 16, plus the 1 is 17. 2 times by 7, which is 14, plus the 1 which is 15. If I add up my answers, I get 5, 5, 10. So I'll carry the 1 across. 5 plus 2 plus the 1 which is 8. And that's my final answer. So the final answer should be 8,055. Thank you very much for watching. If there are any mistakes, let's see if you can find them.